You're going to need to learn how to solve absolute value inequalities, but before we learn how to solve them, I just want to look at learning how to set them up, because you have to set them up correctly in order to solve them correctly. So if you can master how to set them up, the solving part becomes easy. So first thing we want to look at is, what does the absolute value of 3x plus 6 greater than or equal to 12 mean? Well, if you remember, absolute values mean distance. This is telling me that this expression, 3x plus 6, is a distance greater than or equal to 12 from 0. Okay, so I'm going to write that in here. So 3x plus 6 is a distance greater than or equal to 12 from 0. Okay? So now we need to look at how we could set this up using a number line. So here's my number line. Here's 0. Well, if 3x plus 6 is a distance greater than a 12 from 0, that means 3x plus 6 could be out here anywhere past 12, right? So anything out here could be 3x plus 6. Well, doesn't that also mean that 3x plus 6 could be anywhere over here? Because if I'm further back than negative 12, aren't I then also a distance of more than 12 from 0? So what I'm saying, or what I'm seeing here based on my visual representation, is that 3x plus 6 can either be, and I should have had closed circles here because of the line underneath, so 3x plus 6 can either be less than or equal to negative 12, or 3x plus 6 can be greater than or equal to 12. And I'm going to right now ignore this now solve for x and graph the answer, because that's going to be in the next video we watch, which you're going to see is going to be a template just like this. Okay, so for right now, all I want to do is set it up. I want to show that 3x plus 6 can be further back than negative 12. So here's a graphical representation. Here's an algebraic equation representation, or algebraic inequality representation. 3x plus 6 can be further than 12 out here. So in other words, 3x plus 6 can be greater than or equal to 12. So notice what I've done is I've taken this inequality that involved absolute value bars, and I've rewritten it in a way that does not have absolute value bars, which is fantastic because we want to be able to get rid of those absolute value bars in order to solve. So let's look at the next one. What then does 2x plus 6 is less than or equal to 8 mean? Well, again, and there's supposed to be absolute value bars on there, so I'm going to put those on there, and if you want to add that onto your notes, it does make a difference. I think I even read it with them on there because I knew they were supposed to be there. So absolute value of 2x plus 6 is less than or equal to 8 mean. Well, absolute value bars mean distance, so this is telling me that that expression 2x plus 6 is a distance of less than or equal to 8 from 0. Okay, so I'm going to write that down. So 2x plus 6 is a distance less than or equal to 8 from 0. Okay, so 2x is a distance of less than or equal to 8 units from 0. So again, let's look at a number line. So if here is 0, and here is 8, and say here is negative 8, this expression 2x plus 6, if it, and I'm going to do closed circle here, if it falls anywhere in here, then isn't it a distance of less than 8 from 0? Also, if it falls anywhere in here, and again there's a closed circle because of the or equal to, isn't it a distance of less than 8 from 0? So I could either do two separate inequalities for this, or I could just notice that 2x plus 6 has to be in between these two boundaries here of negative 8 and 8. So how do I show that? Well, I can show that with one compound inequality by saying that 2x plus 6 is either greater than or equal to negative 8, and 2x plus 6 is less than or equal to 8. So it's in between negative 8 and 8. There's my setup. Okay. I believe there's one more. Okay, so let's look at this one here. So we want to set this problem up. So first thing I want to do is I want to isolate the absolute value bar just like we did in solving. So I'm going to go ahead and add 5. I could probably show that step. And divide by 3 because I cannot distribute into absolute value bars, and I get the absolute value of 2x minus 4 is greater than 4. So I want to go ahead and set that up. I'm not worried right now about solving it. So setting this up, that is telling me that 2x minus 4 is a distance greater than 4 from 0. So in other words, if it's a distance greater than 4, it could be somewhere out here. Or if it's a distance of more than 4 units, it could also be somewhere back here. It can be in either of those two places. So last thing I'm going to do, and we're going to come back to these watch outs in the next video, that means that 2x minus 4 is either less than negative 4 or 2x minus 4 is greater than positive 4, because either of those situations would satisfy my original inequality. So it would put me either back a distance of more than 4 because it's back here, or a distance of more than 4 because it's out here. And like I said, these are we're going to talk about in that next video. So this is how you set them up. The next video will actually go through the solving process for them.